Hello everyone. Now we will do the question number 13. A double slit setup is shown in the figure. One of the slit is in medium 2 of refractive index N2. The other slit is at the interface of this medium with another medium 1. The refractive index N1 is not equal to N2. The line joining the slits are perpendicular to the interface and the distance between the slits is D is given. The slit width are much smaller than D. A monochromatic parallel beam of light is incident on the slits from medium 1. A detector is placed in medium 2 at a large distance from the slits at an angle theta from the line joining them, so that theta is equal to angle of refraction. Keep in your mind, theta is the angle of refraction of the beam. Consider approximately parallel rays, the slits received by the detector. Which of the following statements are correct? Now just observe that what is happening. From ray is coming from N1 medium to N2 medium. So see here, these are the N1 and N2 mediums. I am writing here. One ray is incident on this point, another ray also incident here. Let us consider angle of incident is alpha. Almost all it is parallel. Let us alpha. Now you consider this is the A point, this is the B point. Okay. Now you can see in this N1 medium, the first ray 1 is traveled more distance than the wave 1 is traveled more distance than the wave 2. Now you can see this is the C point. It is covered extra distance. If it is alpha, this is 90 minus alpha, this is alpha. Okay. Now you can see distance also. This is another point. Let us consider this is the D. This is given D. Okay. Now according to the situation, you can see it is going like this and incident here. This angle of refraction is given theta. Okay, it is take the straight line. Here also it is bending like this and making angle theta. If it is theta, we can see the rays are after refraction, it is going like this. Now if you extend this, something both are meeting at particular point and here detector is there. Now we don't want this all path difference you need to calculate. After this, whatever rays are reaching that point, no, that is same. Now you see here, these rays are almost all, okay, don't consider these all. These rays, no, actually you can see that almost all going like this and meeting at particular point. Okay. Now you see what is the path difference between this. It is N2. Let us draw the one perpendicular line here. This point let us consider E point. If it is theta, this is also theta, this is D. You observe this carefully. If you observe this carefully, this is D. If it is theta, this is also theta only. This is also theta only. Now we can see what is this angle. If it is D, we can write D tan theta is BA distance. BA distance is D tan theta. Now we want this distance CB in N1 medium. It is making angle alpha. This CB value can be written as D tan theta into sine alpha. Now you want this also. If you observe this is making angle theta, this angle is theta. Okay, observe this carefully. This angle is theta. Okay, this angle is theta. If this angle is theta, now you can write AE value is D tan theta into sine theta. Okay, now apply Snell's law. If you apply Snell's law, N1 sine alpha is equal to N2 into sine theta. Now you apply delta x value. The path difference here can be written as N1 into D tan theta sine alpha minus second, it is N2 medium, N2 into this much distance. Here N1 into that much distance. N2 into D tan theta into sine theta. Now you can write the D tan theta is taken common. We can write N1 sine alpha minus N2 sine theta is there. According to this Snell's law, both are equal only. If both are equal, we can write it as delta x is equal to 0. If delta x is equal to 0, constructive interference will take place. Constructive interference is taking place. If constructive interference is taking place, you can write phase difference between the two rays is independent on the D. Is it correct? Okay. Why? Because delta x value is 0. The two rays interfere constructively at the detector. This is also correct. Phase difference between the two rays depends on the n1. So they are not depending on the n1. So you can see that delta phi is independent on n1 n2 d. Okay, the phase difference between even whatever theta is, it is not depending on that. So it is angle of incident beam. They have given the phase difference between the two rays vanishes only for certain values of d, and angle of incident for the beam with theta is being corresponding angle of refraction. So these two are wrong. So correct options are A and B. These are correct options. Thank you.